let's look at the root node. Root node is that we start with the entire data set, the whole thing. We have not performed any splits at all. So that's our root node. At the root node, okay, there are two possible values for target. So what is the proportion of non-owners? And then what is the proportion of owners? Okay. And we can do that by simply dividing the total non-owners by the total number of observations. So that will be like G31 divided by I31. Right? So since it's a binary target, just 1 minus P sub 1 is going to be P sub 2. Okay. So now the Gini index, okay, so that's the formula. So we have 1 minus, okay, P sub 1 squared minus P sub 1 squared minus P sub 2 squared. So that's the Gini index. Okay. Now, if you want to look at what are the possible values for Gini index, so suppose if P sub 1, let's look at it on the side here. Okay. So P sub 1 and P sub 2, right? So let's start with 0 P sub 1. Yeah. What?
What did you put the equation for Gini? You said 1 minus the proportion of...
It's there in the file. Did you see? Okay, so it's right here. It's in the book too. Okay. So let's look at different values for P sub 0, P sub 1 and P sub 2. So P sub 2 is simply 1 minus P sub 1, right? So let's look at this in increments of 0.1, right? So that plus 0.1. Well, that plus 0.1. Okay. So then 1 minus that is P sub 2. Okay. All right. Now if you copy the Gini index formula here, okay, and then if you plot it, and you see that's what the plot looks like. So the Gini index will be 0, okay, if you have a pure node. If the node is completely pure, that is either all of it is 1 or all of it is 0. Okay. In these two cases, Gini index will be 0. So that's why you see 0 here and 0 on the other side. As the impurity increases, as you have a mix of zeros and ones, the Gini index goes up, and it is maximum when there is equal number of zeros and ones. That's the maximum impurity, the equal number of zeros and ones. Yeah, you have a question?
What did we chart? What's actually charted? What's the line?
The chart is the Gini index.
So I didn't see where you expanded that. That was the formula that you pulled from.
Yeah, this Gini index formula that I set up here, I just copied that there. Okay? So as you start off with, I don't know, in this particular example, root node had 50-50, but that's not necessarily the case, because remember in the bank example, I think it is like 90% 0 and 10% ones, right? So Gini index is going to be somewhere around here. And as you branch off, the Gini index will go down and down and down, because it's going to get purer and purer from that point forward. Okay? So we start out with the root node Gini index. And the same is true with, okay, let's look at entropy. So entropy is loosely translated confusion. Okay? So in other words, how impure it is. Entropy is a measure of impurity. So, and this formula is negative, okay, P sub 1, right, times logarithm of that probability, okay, to base 2. Okay. And then minus P sub 2 times logarithm of P sub 2 for base 2. Okay. Now, the maximum value for entropy is 1. Okay. So once again, we can compute entropy here, and I'm just copy pasting the entropy formula from there. But at the extremes, log is going to be, you can't have logarithm for 0. So in both cases, because of P1 being 0, you get an error. And in the last case, P sub 2 being 0, you get an error. So let's do this. Let's make this slightly different from 0. And this one, let's make it 0.9999. Okay, so that way we get some number. So there is no error. Now, if you take the log worth and plot that, again, you see, you get almost the exact plot, except that this goes up to 1 for 0.5. So when you have maximum impurity, which is when you have 50-50, that's what's going to give you maximum impurity. Entropy is going to be 1. Otherwise, it's going to be smaller than that. So that's for the root node. Okay, so now what we want to know is, for a given candidate for splitting, so you have to consider a split, how do you evaluate a given split? And then we will repeat that same evaluation for all the possible splits and select the best one. Okay, so that's what we're going to do. Now, so let's see how to compute these two measures, Gini index and entropy, for one particular split.